It's 11:15, so we're gonna get started. Over to Melissa with introductions.
Hi everyone, my name is Melissa and today I'm with Dr. Dwivedi here. And today we're going to be presenting about sustainable aviation fuel production in the Southeast United States. He is a new professor to our department. Before he was at University of Hilliard. All right, and then he has some introduction slides that he would like to do to introduce himself.
Okay.
Yeah.
Thank you so much. So my name is Puneet Dwivedi, and today I'm going to talk about sustainable aviation fuel production in the southern United States or southeastern United States. I have never figured it out what's the difference between these two words. Let's stick with US South, easy to say, easy to pronounce, right? And as you know, as just Melissa mentioned, I just started here 2.5 months back. So if you see me roaming around in Luhansk, I'm not trying to spy on you. I'm just trying to figure it out how to get to my room. Fine. I think in this new job, Luhansk is the toughest thing so far. Yeah. Right. So I welcome all of you and thanks for your time. And today we are going to talk about something very exciting because millions of dollars and a lot of careers can be made on sustainable aviation fuel. The way things are happening as I speak. So first things first, let me introduce you a little bit. So that if start talking about University of Georgia, you know where I'm coming from. And it doesn't work, perfect. Or it is working now. So I did my doctorate in bioenergy, forest policy and economics. Dilesh was my buddy at that time because he was in the next room where I was, so that was nice. We were together there from 6 to 10, doing a lot of work on bioenergy, forestry, just name it. After that, I graduated in 2010. As you know, there were no jobs in 2010. Market was totally lost. So I was figuring out what to do with my life. And then basically there was a postdoc opportunity at Yale. So I went to Yale to do my 2 years of postdoc from 2010 to 2012. And there I worked internationally, basically looking into why people don't use improved cooking stoves. Though they know that those stoves are killing them day and night and things are really terrible. And again, 2012, no jobs. And I always wanted to be a faculty member no matter what. But again, as you know, if you want something, God has a plan for you. So then I got another postdoc fellowship at University of Illinois at Urbana-Champaign. And then again, postdoc was on bioenergy, looking into agriculture feedstocks for making cellulosic ethanol. So that was nice. And then finally, universities started hiring 2013. And then University of Georgia announced a job in forest sustainability, first job in the entire history of forestry, to be very honest, who talks about forest sustainability. So I was desperate for a job. I was tired of postdocs. So I applied for it and they liked me enough to give me a job. So I started a faculty position at University of Georgia in October 2nd, 2013. And then I was there for 11 years. And 2 months back, I moved to Clemson University to start full professorship and also endowed chair in sustainable forestry. So far, so good, except Luhansk, as I just told you already. And then I also manage 3 journals as a student editor. I am very active in forest policy economics. All the papers which are based on US, Canada, India, basically they come to me more or less. Then I am definitely making some decisions on trees, forests, and people because they have given me full access to decide on the papers that are coming. But obviously, a lot of papers are coming because last year we were like 400. This year we already are touching 700 papers. Nightmare to be associate editor, and one guy left, so it's become more work. Then recently I started to edit Nature scientific reports, and I think I'm the only forestry guy for this country on that particular editorial report. So far so good, but apart from all these professional things, I also have a family life. Me and my wife are together from grade 7, so that's nice. And then I have 2 pets, I call them. They want pet, but I always tell no, that's not going to happen. 2 are good enough for me already. So they are doing great actually. And as you can see, my older one is really tall. She's already touching my ears. So I don't know. I wish she doesn't grow anymore. Right. So for today's outline of the seminar, I'm going to talk about background because background is critical to understand where we are and where we are heading to. Then I'm going to talk about feedstocks, especially looking into 3 or 4 common feedstocks which are very popular when it comes to production of sustainable aviation fuel. Then I get to conversion technologies. Then I talk about role of carinata. How many of you heard about carinata before I spoke about it? Only one. Okay, that's good. You should know about it for sure. Then I come to role of woody-based feedstocks, and woody-based feedstocks are not monolithic like carinata. There's a lot of flavors in it. So I will give a little bit more time on woody feedstocks. And then I talk about carbon intensity, unit cost, and abatement cost when it comes to using wood for making sustainable aviation fuel, if you take into consideration the supply chain part of it. Right? And finally, I discuss few things based on my knowledge, understanding, and experience, what we should be doing and what we should be careful about. And finally, I conclude everything and open the floor for Q&A. But this being said, I'm from India, I speak fast, okay? If you do not understand anything, feel free to stop me, right? Actually, that is better for me as a speaker. So first things first, who flies? Perfect. So I don't have to convince you how important it is to have your carbon footprint as zero as possible, right? So this is a story of jet fuel consumption. All of it is coming from petroleum right now as I speak. At the global level, we are consuming almost 100 billion gallons of aviation fuel each year in the world. That's a big giant number. Okay? And this industry is very vital, especially for Atlanta, because every third person in Atlanta works for the aviation sector, give and take, directly or indirectly. And same is the story in a lot of cities, right? So hugely important industry to take care of our transportation needs, jobs, requirements, economics, taxes, safety, security, you just name it, everything is there, right? Do not forget food, right? It's a really lousy, but you have to eat something if you're flying for 10 hours, right? Coming on to US. Before COVID 2019, we were consuming 24.5 or 3 billion gallons of fuel each year. Okay, I will not talk about COVID numbers because world changed and it dipped quite a bit. But as you can see, 2023, we are more than what we were in 2019. And reason is very simple. More and more people are flying. More and more people are flying internationally. Right? So this number has to go up in the future as we see things on our side. Now, do not think that jet fuel is only used for flying you from one place to place B. A lot of people have private planes, right? If you remember, Taylor Swift was in news because of excessive use of jet planes, private jet planes, right? So these are those guys. And then we also have Air Force, right? Or military or Pentagon, which uses a lot of aviation fuel. 80% of aviation fuel consumed by Pentagon is basically for Air Force, which is okay because they are Air Force, their job is to fly, right? So do not think that aviation fuel is only needed to move you from place A to place B, or get your stuff from China, or get your fruits from Argentina, especially in winters. But we also need it for national defense and definitely to take care of businesses, especially all these big giants who are actually running the country. Okay, makes sense? Now, one thing I forgot to mention, overall USA consumes 25% of all the fuel consumed in the world. That's a big chunk of overall aviation jet fuel market. Okay, huge. Now, this is the southeastern states. So as you can see, these 12 states, and I know West Virginia is always, who knows where it is in terms of geography, but I put it here just for the sake of it. But exactly, their contribution is zero to the overall jet fuel consumption in the country. It's such a small state, right? But nevertheless, if you see this number in southeastern states, all 12 of them, basically they consume 25% of, give and take, of all the fuel consumed in the country as such, right? So that number comes out to be almost 5 million gallons of jet fuel per year. And why that is the case? Because if you see the 10 busiest airports in the country, Atlanta is number one, of course, not in the country, in the world, right? 4 of them are located in these 12 states. Atlanta, then we have all our things in Orlando and Miami, and then Charlotte, which is not very far from here, right? And together they control almost 40% of passenger traffic in the country. It's not a big surprise that they are consuming almost, or these southern states are consuming almost 25% of total aviation fuel consumed in the country as such. Okay, so any questions, clarifications? No? Moving on, the biggest problem that why we have this seminar to begin with is basically aviation fuel is coming from petroleum, as we know, that is fossilized carbon and we are burning it, and then all that carbon is going into the atmosphere. And the aviation sector has a bigger problem because they emit a lot of that carbon at 35,000 feet. So whatever they emit has much more intensity of impacting climate change than something else which is emitted on the land. So overall, based on all the science we have, the aviation sector at the global level is responsible for 3.5% of total climate change as I speak. Okay. Second thing is that, again, coming back to US, emissions, carbon dioxide emissions from aviation sector in the country, they are almost 3% of all the carbon dioxide emissions in the country. So now you'll say, oh, why we are worrying so much about 3%? Like it's very little number. We have to worry about a lot of other things which are emitting more than 3%, right? But the problem is all other sectors which are related to energy, they are decarbonizing fast. For example, electricity. We used to make all of it from coal. Coal is a history when it comes to electricity. Everybody is moving to natural gas, easy, cheap, and clean, right? Second thing, look about your gasoline consumption. People are moving to electric cars, which in turn is drawing energy from a very clean grid, especially what was it long time back, right? So every other sector is decarbonizing. Aviation sector is 3%. If they don't decarbonize fast enough, they will be 20, 30% because everything is going down. Right? And they don't understand, these are small people, I deal with them all the time. So that is why they are trying to get rid of their carbon footprint as fast as possible to make sure that they have social license to operate. Especially new generation, which is very careful about their carbon footprint and climate change. Okay, and so that is the driver behind all the sustainable aviation fuel movement. And why sustainable aviation fuel? Why not something else? Reason is very simple. If you see where these emissions are coming from, when you're talking or thinking about a plane, for domestic flights, 80% emissions come from fuel. International flights, because they fly longer, right? 95% emissions come from fuel. So no matter what the aviation sector does, if they are not taking care of their fuel, practically they cannot be carbon neutral ever. And the biggest problem with the emission sector is they cannot fly a plane on a battery because batteries are heavy, and as we all know, weight is the enemy of the aviation sector, number one. They can do anything to reduce the weight, right? So considering all the things, they have figured it out, something needs to be done, and as a result of which, their big giant organization, International Air Transportation Association, basically all these big giant airlines, they are, and smaller ones too, everybody is part of this group, association, which lobbies on behalf of them. They came together, saw all these numbers, see basically what other sectors are doing, what we are doing, and they have figured it out that if we don't do anything, we will lose the moral authority of flying planes because we will be the number one pollutant in the world, right? Especially when it comes to all these energy intensive sectors. So then say, okay, no worries, let us have some policy targets. The first policy target is that we are going to have 65% sustainable aviation fuel. Second one is that we are going to adopt new technologies, electric and hydrogen including, to get to 13% of emissions, and then 3% in terms of infrastructure and operational efficiencies, and still they are sure that they will not be able to get all the carbon they want to get to net zero target. So they are also talking about some offsetting. Okay, so a lot of things that they have decided to do, but as you can see, most of the things are going to happen in SAF space because as long as they have not taken this into account, they cannot be carbon neutral no matter how hard they try because mostly all their emissions is coming from fuel. Okay, so Delta, biggest airline in the world in terms of everything, revenue, passengers, planes, you just name it, right? They have a target of getting to SAF 10% by end of 2030. And Delta is not the only one. Almost all the major airlines of the world, not just this country, have some targets at how much SAF they will be consuming by 2030 and then by 2050. Because the overall target is to be carbon neutral by 2050 as an industry. Okay, so a lot is happening because of all these things. When Delta fell in trouble because of COVID-19, they cut their budgets everywhere because they wanted to survive, nobody was flying, except their sustainability division, which is managing SAF, because Delta is very committed to this particular goal to get to net carbon zero as fast as possible. Right? So considering all the things, White House also started a new challenge. We call it Sustainable Aviation Fuel Grant Challenge, that the country will be producing 3 billion gallons of SAF by end of 2030, just to get a flavor of it, right? And then the idea is for the next 20 years, starting 2030, the target is to get to 35 billion gallons of SAF, so as to make sure that whatever fuel we are going to consume in this country is totally carbon neutral without sacrificing the services that come out of aviation sector. So opportunity is huge. We are not producing even 1 billion gallons right now, and the idea is to get to 35 billion gallons in next 25 years. So that is why so much of investment is going behind this, to make sure that we get what we want to get. So now, best part of it, where we come in as a natural resources school. You can get SAF from a lot of feedstocks, but I will talk about little bit about MSW, which is basically municipal solid waste, and then I will talk about agriculture, little bit where Carinata comes in, and then I will talk about forestry, right? So let us go one by one, so as to make sure things are as clear as possible. So MSW is municipal solid waste. We do not have a problem of waste in this country because we generate a lot of it, right? Almost 50% of food that is produced goes to landfill. Think about it. That's a pure nutrition food that can be eaten and synthesized, right? And methane is where all the natural gas is because of all that decay of food that we keep throwing in our trash bins, right? So of lately, a lot of people have figured it out. That's a almost very cheap feedstock that can be used for making sustainable aviation fuel. So this new company started a pilot plant in Cordell, Georgia, which is like 3 hours from Athens. And they are basically trying to figure it out with the city of Cordell to get their food waste and all the farm waste, because Cordell is the like capital of farming in Georgia, and all that, and put it into their technology to produce SAF. And the idea is to, if it works, they will ban it out. At the same time, they're also in touch with city of Atlanta to get all their waste, especially from all these big giant stadiums, which keep doing almost something every day, and basically trying to use that waste to produce sustainable aviation fuel. And the best part is that if you can do in Atlanta, Delta is there, you don't have to worry about anything. Right, so a lot of movement is there on MSW to produce sustainable aviation fuel in the future. Second thing is that agriculture, and since only one person knows about Carinata, actually two, me including. So let me tell you a little about Carinata. I will not go in details, but I will give you a good reference so that you can go and check it out. So Carinata is an oilseed crop. Do not even think about eating it, because then you are dead. Nobody can save you. Okay, there is no antidote, nothing. This is not for human beings, bottom line, which is good, because if you can use it for making sustainable aviation fuel, then basically you do not have a problem of food versus fuel, which comes when you're talking about getting your ethanol from corn or biodiesel from soybean, right? So Carinata is a no food crop, especially for human beings, not good. It is an oilseed crop, and the best part is that it grows in winter months where we do not grow any crops, especially in US South. And it fits really well to our agriculture rotation, which is basically cotton peanut. You can fit this crop in winter months between 2 cotton crops without thinking twice. And as I just told you, flowers is not a problem. As you can see, if you go there in the spring season, it's like so many bees I've never seen in my life at one place. Everybody is fully drunk and they are really happy with all the pollen they are getting. Right? Really, they cannot even fly, they are so heavy themselves. Falling when they are flying, yeah. It's amazing to see those bees and everything else. And the good thing is that once you harvest your seed in May or June, then basically these are the seeds, as you can see here, right? You can crush them to produce oil, which is here, unrefined filtered oil. You can refine that crude oil into a nice looking yellow liquid, and then you can further process that liquid to make 3 products: jet fuel, naphtha, and diesel. Okay, so diesel everybody knows, jet fuel everybody knows. naphtha is a very important industrial chemical because it's a universal solvent. So if you eat chocolate, naphtha was used. Like there is no question mark there, especially of all the large scale chocolate making. Okay. And then the other part is that nothing goes to waste. All the leftovers after crushing the seed, they can be further treated to produce high protein diet for animals. Because if you treat it, animals can eat it. Still, being a human being, I will not eat it. I don't want to die for sure, right? So long story short, really remarkable crop for South. It helps land because we are using it wisely in winter months because it gives all the benefits of cover crop, better moisture retention, better pollination, better carbon. It also sucks up all the nitrogen that was used for growing corn or cotton. So overall, water quality improves, overall really nice crop, and plus you get sustainable aviation fuel, which is in high demand anyways, right? So I was working on this project from last 6-7 years, and finally we were able to put bunch of people together working on a lot of aspects of growing carinata in South. And then we did a special issue which was published in GCB Bioenergy. So if you want to know more about carinata, you can go and see this is special issue. If not, at least see the history of this crop. It's just amazing. Also, my students from Canada went to Ethiopia and got the seed to Canada. And Canada, they figured it out that we cannot grow too cold, right? So then they basically went to Florida and Georgia to do all these trials, and these trials have been remarkably successful to the point that British Petroleum gave billions of dollars to the company who is behind carinata to connect with farmers and start with carinata so that they can get all the oil and seeds to produce sap and supply to United. Actually happening, and a lot of people are doing really remarkable work on carinata and agriculture, especially in the US South. There are other crops too, but I don't know how successful they will be because they're really good for Midwestern states. But again, in Midwestern states, they have better crops who give more money to them, so adoption is an issue. But carinata should work, and it is already working. And this time they did not go for any contract with farmers because demand of carinata seeds is so high that company ran out of seeds. So that is a good problem, especially when you're talking about scaling SAF production in the country. Hopefully next year will be a really good year for the company. Now coming on to forestry. How many of you are forestry students? Okay, some of you. So let me tell you a little bit of basics and then I will go a little bit more deep because I knew there will be not many people who have forestry background, especially in this audience. So first thing first, forestry is huge. Okay, in South, there are 171 million acres of private forest lands. All are really productive, right? And US South is also the capital of wood production in the world, forget about country. Okay, 10-15% of total wood harvested in the world is harvested in these 12 states. So we are really fortunate to have such a great resource, basically in our background, right? Total jobs that are supported by forestry sector, direct and indirect, almost million jobs, including mine, right? Then labor income, the people, income, that money that goes to home in terms of salary and whatnot, almost $55 billion each year. Total contribution to GDP, almost $100 billion each year. An important sector for this part of the country for sure, right? And plus, people don't even think about it. Free carbon, right? Free water, really good quality water. You can drink it directly. You don't have to filter it, right? Air, clean air, very important. And then recreation opportunities, right? Hunting, swimming, kayaking, you just name it. What else I'm missing here? Any idea? Habitat, biodiversity, all the species which is not human beings. Well, some human beings also live in forest, but most of the species, they live in forest, and that is why we need forest. That is the service of forest to us, right? Because we use those species for a lot of other things. Make sense? Okay, so important sector for the South. Now, coming on to how much we harvest each year, right? So these numbers that you are going to see, these are basically numbers when it comes to harvesting anything which is 5 inches diameter or more. So basically pulpwood. Okay? And we use pulpwood for making paper, but we also use pulpwood for something else, which you use first thing in the morning. which is your toothpaste. So if you go and check it out, toothpaste, it has a lot of tree in it, 50-60%. That is how toothpaste company makes so much of money. They are selling 1% of real stuff and 99% of tree to you, right? So as you can see, we harvest almost 183 million dry tons of pulpwood and above wood in US South. And as you can see, Georgia, Alabama, it's very difficult to beat, huge states with a lot of forestry. But South Carolina is not far behind, but almost average, and then there are other states which are low. But at the same time, people don't understand, we also harvest a lot of biomass, which is 1 inch and above. Okay, and all the biomass which is in between 1 inch and 5 inch basically goes for making power or heat. Okay, the original number that I showed you before was 183, but if you include anything which is 1 inches and up, you are talking about 200 million dry tons of biomass each year coming out of that private forest lands. Okay, so if you subtract these two numbers, you will find out that potentially 17 million dry tons of wood can be tapped for making sustainable aviation fuel. But already people are using some part of it, right? So I'm making a very conservative estimate that 33% of it can be used for making sustainable aviation fuel. Logging residues, whatever is left when you have harvested everything, right? Because you cannot do anything about it because there are no markets for it. Right now, we are at 60 million tons because of all the wood that we harvest each year, right? And we practically don't do anything. We just leave them as such, or we burn them if we are really desperate. But burning is becoming very problematic because of pollution problems and because of liability issues. So mostly we harvest all the wood, especially pulpwood and up, and whatever is left, which is non-merchantable, we just leave it for the future, right? But that is wood at the end of the day, and that can be utilized for making sustainable aviation fuel. So I'm assuming that you can use again 33% of it for sustainable aviation fuel production. Okay, so summarizing everything, so net removal 6 million dry tons, right? Logging residues 20 million dry tons, and then we harvest a lot of pulpwood, almost 100 million tons each year to make papers and type stuff that is the absorbent material for diapers and so on and so forth. But still, as we all know, paper demand is going south. Nobody is writing on papers, that's a few people, which is okay, really good job. Right, so I'm assuming and projects are closing in and out, especially in south, because people were thinking when the interest rate will start going down, housing market will pick up. But instead of mortgage rate going down, it went to 7.1%, which is like amazing. Who knows what is happening in economy anymore? But nevertheless, I'm assuming since all the people are closing their shops, you can also get hold of at least 20% of that pulpwood for making your sustainable aviation fuel, right? So together you can get up to 46 million dry tons per year and do all the calculations, and we need almost 2.5 billion gallons of SAF each year because you cannot go 100% replacement right now. The blend that can go into the plane is 50-50. So we are consuming 5 billion gallons of fuel each year, right? You can go up to 2.5 billion gallons of mixing of sustainable aviation fuel. So basically we need 2.5 billion gallons of SAF, right? So if you do all the calculations, you can find out that forestry feedstocks that I refer to, they can displace almost 75% of all the SAF we need as I speak. And this number is very, very conservative.
Is this from the south?
This is all the wood from south for the southern states. I'm not talking about country, right? So 25% of all the SAF we need, or 75% of all the SAF we need for the 12 southern states, right? That can come from wood without thinking twice. Now, one thing very important. That is where people go wrong when it comes to bioenergy and woody feedstocks. Do not try to source your biomass from bottomland hardwoods. Like non-profits will come and they will definitely complain about it, which should be the case because these bottomland hardwoods are really good for biodiversity and water and so on and so forth. And that is where a lot of wood pellet mills went wrong because they started sourcing from bottomland hardwoods because they thought if paper mills can do it, why we cannot do it? But paper mills are making a product where people can feel and touch. energy is a different ballgame. How many of you have seen a aviation fuel in your life? Nobody, right? Tia has seen it. I don't know how, but that's what we did. Yeah, so that's the thing, not many people even see energy products, right? We just put it and we use it and we forget about it and we need it, we get it, right? But so energy is a different ballgame than a lot of other things that we are so used to. So be careful, especially for industry, not to go to bottom and hardwoods to get your wood for making sap. Just focus on the plant, softwoods and hardwoods, plenty of land, plenty of biomass, and hopefully you are not falling in trouble when it comes to a lot of other issues when you are trying to source your biomass, right? Second thing, coming on to technologies, there are too many of them. So all these technologies are approved where you can use them, get money from investors to make sustainable aviation fuel. And these technologies, as you can see, they are under deliberation. Okay, now two things. These two technologies are very popular, HEFA and CNJ, to make sustainable aviation fuel using your cooking oil. Okay, used cooking oil. McDonald's make more money by selling used cooking oil than selling burgers. Things are so bad that in Athens, Georgia, 1 year back, people rented a Home Depot truck, went to Wendy's in the night to take away all their used cooking oil and sell it for SAF and making biodiesel. And now Home Depot is suing each other out because of what has happened. Right? Because you should not use Home Depot property to steal something else. But long story short, jokes apart, the idea is used cooking oil is very important for making biodiesel and obviously sustainable aviation fuel. And these technologies exist to basically get it done. And as a result of which, right now, most of the aviation fuel which is coming from is basically coming from HEFA because this was just approved. And I know the guy who invented it, he lives in Panhandle, Florida. I don't know, next to the sea actually, yeah. Nice guy, great, yeah. Then this is the new technology which is coming out, which is going to be used for biomass and making SAF. They call it FT, Fisher Tropsch. Okay, and I think this technology holds a lot of future for woody biomass to make SAF out of them. It is doable, it is scalable, and most importantly, it works. Okay, so I think there's another one. So this is another one technology which is coming up. It's very complicated, but I think still people are using it because it works basically. But the idea is to take your biomass, ferment it to make ethanol, right? Do not drink that ethanol, otherwise you will fall in trouble. Your intestine will boil out because water will come out of your body because that's 99.99% proof. You don't want to drink that alcohol, right? And then you take that ethanol and do some more technology to produce the air, right? So a lot of people are also thinking about it, especially the kind of investment coming in, but I think it's too complicated. There are better ways to do things. That is, I'm very hopeful about Fisher Tropsch, especially for woody biomass. So for example, this is the new bioenergy company. They have $3 billion to put on the ground to make sustainable aviation fuel using Fisher Tropsch technology. And I met these guys in Atlanta, Georgia Tech for the SAF conference. Interesting people. I mean, they have all the money except $100 million that they are trying to raise, but I'm pretty sure they will be able to raise it and they will find somebody who is willing to host them to start making sustainable aviation fuel. And we discussed few things and I told them, why don't you look there at South Carolina? Because the biggest advantage of South Carolina is we have a lot of wood, cheap wood, plus we are next to Colonial Pipeline, which passes from Spartanburg. So you make everything here, put that SAF into the pipeline, then you can go up to JFK, or you can go to Atlanta, or you can go to Houston. They like that idea, so they want to talk. Let's see how that goes, right? And then the new technology which is coming up, methanol to jet, which is very interesting. Methanol is also known as wood alcohol because that is how we were making it before we figured it out few other things, right? So I'm very happy that ExxonMobil is taking a lead because everybody knows how to make methanol. I can make it in my backyard. It's not very different at all. But nobody knew how to, once you have methanol, how to make SAF out of it. But finally, ExxonMobil, they have enormous resources and money. They have figured it out how to do it. And they are very excited to get an approval first, which they are trying to get it right now. And once that approval come in, ExxonMobil will start making biorefineries on their own because technology belongs to them. And that is a technology, I think, after FT is the next big thing that is going to happen in the forestry sector. Because sustainable aviation fuel, you cannot go wrong. The market is enormous and we supply is practically zero right now. Yeah, so a lot of action. It's interesting to be in SAF world right now. So because of all these things that we just talked about, right now, predictions are that by the end of next year, we will be producing almost 700 million gallons of SAF. And right, but still, that's nothing. We need 35 million gallons, right? But again, everything starts from the first gallon, and at least the trajectory is on the right timeline or trajectory is on the right direction. So that's the best part of it. And the way investments are coming in, the way people are talking about SAF and ExxonMobil and off lately Bill Gates, I think there will be some big future achievement in this space. It's just a matter of time. A lot of money is chasing the technology. So this is a brief general introduction. I know it's a lot, but hopefully you should be able to appreciate why we are talking about SAF and where we are heading as a society when it comes to aviation and hopefully reducing the impact of aviation on the climate change and also giving full-time, good-paying jobs to a lot of people in rural areas because this thing coming in, most of the jobs will be in rural areas, not in cities. Right? Make sense? So with this, all this in mind, we thought just do some more research to figure it out whether or not the SAF makes sense or not. So with that in mind, we means one of my student and I came out with some research questions. I think we are okay. You don't have to do anything now.
Okay.
Yeah, thank you, but yeah. I called him like half an hour back to explain that something was very good. I don't know you, since I'm speaking, I'm really comfortable right now, yeah. So 4 questions, how much carbon is saved for a gallon of wood-based SAF relative to gallon of conventional aviation fuel, right? SAF and CAF, do not go wrong there. What is the unit cost of a gallon of wood-based SAF? Are given economic incentives, and there are plenty of them for producing wood-based SAF or up to the mark. And finally, what's the carbon abatement cost to make sure that we can produce sustainable aviation fuel from wood relative to conventional aviation fuel. And I wanted to analyze all these things at the supply chain level because that is where all the action is. Another reason for that was that we already did similar kind of analysis on per acre basis. But when we published this paper, a lot of people came back to me, including people from data, saying that this is all fine for academic. But actually, we cannot use it for our purposes because we are looking for supply chains and scales, and we are not talking about 1 gallon of fuel. We are talking about 4 billion gallons of fuel each year that Delta consumes. That's huge, right? So I thought, what you want? He said, we want something on supply chain side. Can you do it? Well, yeah, we can do it. Let's try to doing it. And then we thought to do this case study for Georgia for obvious reasons, because 2.5 months back, I was at University of Georgia, right? And second of all, Georgia is one of the biggest forestry state in the world, or in the country for sure, #1 forestry state with 22 million acres of forest lands and so much of biomass production and so on and so forth. And plus, it's very surprising, Georgia is very heavily forested, even in Atlanta area, right? It's just amazing, trees are everywhere. I was in Phoenix 1 month back or 15 days back. Oh my God, I cannot tell you that how I'm so used to trees when I landed on Phoenix. It was just like shock for me not to see a single tree there. Right, second thing is that in Atlanta, we have also, I'm not wrong that Georgia is in Atlanta because that is the case, but taking it back, Atlanta is in Georgia, right? So as you can see, Atlanta alone consumes 1 billion gallons. So we have a lot of supply in terms of woody feedstocks, and plus we have huge demand in Atlanta airport. So Georgia makes a lot of sense when it comes to doing this kind of research at the supply chain level. And plus Delta's headquarters is in Atlanta, so Georgia was a perfect case study for this kind of research. Right, so as I told you, Georgia is big in terms of harvesting. So if you see the distribution of all the harvesting and all the lawing residues which are coming from hardwoods, basically all the oaks, you can see we have almost 2 million metric tons each year. That's a huge resource which does nothing right now, practically just lays down there and decays, right? And also we have softwoods, which we produce almost 3.5 million tons per year. And I don't know how many of you know this part of the world is the pulpwood capital of the world. Right? Majority of the pulpwood in the world is produced here in these 50, 60 counties. It's just amazing how much loblolly pine is standing there if you take a county road and start driving. Right, so this was our system boundary. We had all the counties which are going to supply log residues to us, right? Then we have biomass processing units which will process that biomass to make sure that it can be supplied properly to biorefineries where the sustainable aviation fuel is produced. And once you have that sustainable aviation fuel, you supply it to Atlanta Airport because as I told you, they can take all of it without thinking twice. Right? And also the technology that we are using for this paper, which I will talk about in a second, that apart from producing sustainable aviation fuel, it also produces electricity. It also produces renewable diesel. It also produces renewable gas. Okay, because these molecules are almost similar. So if you want to produce more, you will definitely produce something else. So this is the technology, ATJ, alcohol to jet. Right, I'm not very big fan of this technology, but data is very limited when it comes to these conversion technologies. So we only got that data which is publicly available, right? So you take biomass, you hydrolyze it to produce basically ethanol, right? That we know from last 2000 years how to make ethanol from food, right? And then you dehydrate it. Again, do not drink it, okay? That is where the problem starts. It's very high in ethanol. It will basically starts reverse osmosis where your body is releasing water, right? And then olefins and all that chemistry and whatnot, but at the end of the day, you get SAF, but you also get diesel, electricity, and your gasoline, right? And for this technology, you get almost 34 gallons per dry ton of biomass when it comes to production of sustainable aviation fuel. Okay? So then we did life cycle assessment to figure it out what is the carbon intensity of sustainable aviation fuel produced using the technology and using the biomass at the supply chain level. So we also accounted for all the distances. Okay? And Georgia is a big state, keep that in mind. Double the size of South Carolina, if I'm not mistaken. We also did unit cost analysis to figure it out what is the cost of production for all the SAF, because that number is very important for all the policy making in the country. Then that is our actual contribution is, which is on top of the paper we already published. We spent 3 years to write these equations to make sure they are to the mark and actually work. And I will not go into details, but the whole idea is to minimize the unit cost of production for a period of 10 years, just to make sure that we are getting sufficient amount of sustainable aviation fuel based on the total biomass we have. Okay, so it runs for 5-6 hours to tell all the things. We do not have that kind of time, but the idea is to produce the lowest cost sustainable aviation fuel, which is good enough to displace some amount of SAF or some amount of conventional aviation fuel that Atlanta is using. Okay. So coming on to some results, this is how the structure of supply chain looks like. Okay. So we need 54 biomass processing units to make sure that we have sufficient SAF. Okay, we need 13 biorefineries to make sure that we have sufficient SAF. And sufficient SAF means that we are only displacing 10% of total conventional aviation fuel used by Atlanta Airport. We cannot displace all of it. Atlanta Airport consumption is huge. We do not have sufficient biomass in the state of Georgia to displace all of it. Okay? Cannot do anything about it. That is what it is. Atlanta Airport is huge. They consume a lot of aviation fuel, 1 billion gallons each year. And all the logging residues we have, if you leave 30-40% of it, they can only meet 20% or 10% of the total conventional aviation fuel demand. Right? So we need more biomass. And I always tell people, be very careful about SAF getting big, because then traditionally wood-based industries, sawmills, paper mills, they might get evaporated because they do not have biomass. Everything is going for SAF. Huge market. Now coming on to the biomass, we are consuming almost in general over a period of 10 years each year, almost 4 million metric tons. Right? And we have like 5 or 6 overall to begin with. Out of that, almost 4 is going for making SAF because we are leaving something on the ground for the ecological reasons. Okay, so as you can see, biomass is moving everywhere across all the counties, and then basically it goes to CPUs. Some are in Piedmont because Atlanta is in Piedmont, distances matter. Some is in coastal plain because that is where a lot of softwood is, right? And then basically it goes to biorefineries to get going, and then finally it ends up in your Atlanta airport. I'm also assuming that Atlanta will buy all the SAF. By the same time, all other things will be bought by somebody because all those are commercial products. Carbon emissions, 6.4 pounds of carbon dioxide per gallon of SAF. If you compare that number with jet fuel, which is 21.4. Okay, so basically, which means if you use SAF instead of conventional aviation fuel, you are going to save 70% of carbon emissions. Right? One thing I want to highlight, you see this is negative numbers. This is mostly because we are producing renewable diesel, renewable gasoline, and that goes out and displaces the conventional gasoline and conventional diesel. So you're also getting some carbon savings because you're displacing those really dirty fossil fuel based products, right? The co-products matter, otherwise this number will go up. Okay, but nevertheless, based on all the things we have done, 70% carbon emissions, that's huge. So definitely if you make SAF from wood, emission sector should benefit. Unit cost, that is where all the problem is, okay? If you do everything right and we are trying to minimize cost here in this model, right? You can see it is almost $9 per gallon. And right now the price of jet fuel is almost $3 per gallon. So if you see the numbers, jet fuel, SAF is almost twice expensive related to conventional aviation fuel. Right? But aviation sector is very interested to reduce their carbon footprint, and they are trying to do everything to basically reduce this cost because they know it's a no starter to begin with. And when you realize all these things, you can see that most of the cost is coming from the biorefinery. So that is why all these new technologies that I told you about, they are getting more and more prominence so as to make sure that we are reducing this huge chunk of cost. Because if that goes down, this number has to go down. There is no confusion about it. Okay, that is why FT and this methanol to jet, they are getting a lot of traction because they are scalable and they are much more easier to get things done related to alcohol to jet because this technology is expensive for sure. Now, role of incentives. This is the cost of production as such, jet fuel, right? But you start adding more and more incentives, which are really available right now as I speak. At the end of the day, if everything is perfect and you are really lucky, you can get down to the cost of 20 cents per gallon, which is much lower than the conventional fuel cost, which is almost $3 per gallon. But this is really a wishful thinking. I don't think so that is ever going to happen, right? With all the incentives. But nevertheless, I think this number is a very reasonable number if you start about those incentives which you can actually realize, right? But still, this number is twice of what we are getting from conventional aviation fuel. The long road ahead for the sector so as to get to a comfortable place. A carbon abatement cost, which is basically if you do not have any incentives, government says we are done with you, you figure it out yourself, but government is happy to put a tax on conventional aviation fuel, right? Where basically SAF becomes comparable to conventional aviation fuel in terms of cost, right? The tax will be almost $700 per metric ton of CO2 coming out of your conventional aviation fuel. That's a giant number. That's never going to happen, right? But for the sake of things, I just wanted to highlight this thing. Because if we do not want any market incentives, we want to keep things as simple as possible. Carbon tax is a really good idea if we are serious about climate change. It works, everybody knows how to do it, easy to get it done, a lot of people are there to get it done. So, but that tax has to be $700 per metric ton of carbon dioxide coming out of conventional aviation fuel if you want to support the aviation fuel coming out of woody biomass. Otherwise, actually, these two kind of aviation fuels cannot compete on cost. So long story short, I think this is the last slide. My takes, logging residues can definitely help us in terms of scaling sustainable aviation fuel production. Carbon savings is substantial. It is costly for sure, but again, with suitable incentives and suitable planning, especially long-term planning, it is pretty much manageable if we are serious about it. And then definitely scale matters. Higher rate you produce, more you produce, your cost will be lower than if you go for boutique SAF production. So keep that in mind, and they can vary a lot actually. And right now, we have to educate people that we are cutting trees for good reasons, and plus we are planting it back so that industry has a social license to operate. I started doing some research on certification standards. I think they don't talk to each other, especially the bioenergy sustainability standards and forest management standards. There's a lot of overlap, but a lot of things are totally who knows what they're talking about kind of situation. So they need to talk and they should come into the sync to make sense of everything. And finally, collaboration is the key. Technology is evolving, a lot of risk, investors are looking at everything, but they are investing money the fast, the manner they should be doing. Policymakers don't have any clue about it, to be very honest, still. So a lot of collaboration, a lot of education is needed to make sure that this sector is as successful as possible, especially when all the conventional forestry sectors are basically declining. So this is a new ray of hope, especially in the forestry sector. So with this, I want to acknowledge few people. Ratri is a student working for her PhD on these topics, so I'm very thankful to her. And then Kai was a postdoc with me who developed all these models and a lot of other things. Masoom, again, former graduate students and former postdoc, now is working for Oregon National Lab with Michael Wong in Chicago. And then definitely big thanks to FIA program for giving us all the data that we always ask for. And definitely big thanks to NIFA for supporting this research. And personally, since I'm in South Carolina, I think South Carolina has a lot of potential. And I'm working with the State Department of Commerce to get some money to do some feasibility study. Hopefully they will come along on Monday and give us money to get started on these lines. But since Colonial Pipeline is here, all the biomass is there, Clemson and all these colleges are there, where engineering is not a problem, qualified workforces, they are all throughout the supply chain. So big opportunity for South Carolina, and that might also give a lot of options for our landowners who can potentially sell our wood. Because right now, even for Clemson, selling wood is a problem because the sawmill has closed. We don't know where we will sell our own wood from 17,000 acres that we have. Right, so if this market comes up not very far from here, you don't have a problem of selling wood, right? So with this, I will stop. This is my email. I always tell people if you have any problem, drop me an email. I think I can solve it, unless until that problem is me, then I cannot solve it. Right? So figure it out, and if you want to talk, we can talk more. But thanks again for this opportunity. I'm happy to talk. Yeah.
How much is currently produced with example commercially?
Right now, there's probably nothing. Lancer Tech got some money from GE and big investors from New York City. They are scaling up their production, but do not quote me, but they will fail. Because they're trying to get ethanol from Brazil and make that ethanol converted into SAF. In Georgia, lawmakers know that ethanol is coming from Brazil, they will shut that down next day, yeah. It has to come from US and pine or agriculture or mostly from Georgia. But the problem is that ethanol, they don't want to make it because they can get it cheaper in Brazil, even though they're transporting it. A lot of things are there, but I think they are not dealing with government affairs properly. And that will be a nail on the coffin in the right time, yeah.
So you mentioned that some of the wood products that you can use to make SAF come from like extras from like logging. And so you said that there's usually huge trees that like have a bigger diameter.
Yeah, so bigger diameter trees, they are valuable and wood is very costly, right? So they will not go for SAF because you can make better valuable products out of them, like paper towels and all the other things that is paper. So those 5 inches and up, they will go for their definite purposes. But the little ones, like 1 inch, between 1 inch and 5 inches, most likely some portion of that biomass can definitely go for sustainable aviation fuel production.
What about like leaf litter and like branches and stuff like that? Do they use that as well?
So that will be part of logging residues actually.
Oh, okay.
When the way they harvest trees, all that falls down and basically does nothing. But that is all accounted for logging residues. That is why I was telling that we can use some portion of it for making sustainable aviation fuel.
Gotcha. So would there be any incentive to like work with like residents that have like land and like leaf litter? Because I know that a lot of people clean up their land for like the fall and like they put them into bags in the county. Or
That will be part of MSW, right?
Oh, okay.
Municipal solid waste, because ultimately all that things goes to landfill and decay and produce methane, which is much more harmful than carbon dioxide.
Mm.
So that is why a lot of people are interested in MSWs, especially in cities in south where we have a lot of trees and a lot of lawns. Right? For example, if you do not have 1 acre of house, you're not living an American dream, right? So it might work, yeah. Yeah, please.
So kind of on that subject of like municipal solid waste, has anybody looked at like agricultural waste from animals as a source of, is that possible with this?
Point, a lot of people are interested in those ones, and the technology is, that is actually Bill Gates coming. Yeah, so basically what they are thinking in terms of their technology is put serious money behind the technology. Actually, the name of the company is M2X. And the idea is to basically take animal waste, process it to produce natural gas, like biogas we use in India or Nepal, everywhere, right? That is nothing but methane and methane, and then clean it. And then you get pure methane, and then basically put hydrogen into it to produce sustainable aviation fuel. So that is where a lot of technology is moving to get hold of all the possible type of biomasses, including animal waste, to produce SAF. Because if you can make it, you can sell it, like practically no brainer there. So if you're an entrepreneur or interested on those lines, you cannot go wrong in 3 businesses right now. First one is lithium. You do anything, you will make money. You do SAF, you do anything, you will make money. And third thing is what? Where you will definitely not lose money. Don't do anything, right? That is definitely a way not to lose money. If you do anything, there is always chance of losing money. But between lithium and SAF, there's a huge demand, practically no supply. And lithium is even more problematic because you have to deal with federal government and all the international laws, and we just name it one thing after another. Yeah.
If people do make the SAF out of the residuals from like logging, would that change the price? Was that in your all's calculation? Like, they would probably, the logging company or the landowner would probably want to charge for people to take that.
So we accounted for that one for $2 per ton, but that doesn't, is overall cost, that component is very small. As I just talked about it, most of the cost and emissions are happening at the biorefinery. That is why all these new technologies is coming up, because if we can take care of conversion technology, when we are taking biomass and making fuel out of it, reduce the cost and reduce the carbon impact, then basically you are in the game. Biomass will be a very small component anyway. In fact, more than biomass, transporting biomass adds cost. Because biomass is a high volume, low dense solid, right? So that adds a lot of cost. And that is why you see all those biorefineries and all those biomass processing units, they were basically next to each other just to reduce the transportation cost, because it adds up quite a bit, millions of dollars just for transportation. And in modern world, everything moves, right? Anybody else? Good questions?
Is there any Zoom question?
I don't think so.
Yeah, for Lanzotech, I think they're trying their best, as I was telling. I think they have to be a little bit careful of the governmental affairs, because if people know about it, that where the ethanol is coming from, it will be a problem for them. And my understanding is that they do not have any solid plan where they are going to get ethanol. Everybody is guessing, just like what I am doing, that it is going to come from Brazil. But let's see how that goes. I'm also keeping an eye on them for sure, yeah.
So which among the different countries, who is leading the SAF market right now?
So there are 2 or 3 big companies. First one is Neste. They are the big ones. They're out of Washington area, and they are trying to do a lot of sustainable aviation fuel. And there are and then, gosh, who was on my panel? DG Fuels was the big one. He was on my panel in the SAF conference. And then this USA Bioenergy, they are also interested on basically going big on aviation fuel. And plus, after that, as I told, British Petroleum, ExxonMobil, all the traditional petroleum company, they're also trying to get into SAF world because they know they have to, because conventional aviation fuel will go away in 20-30 years. So they are already preparing for the future. Yeah.
Have you guys done any like projections looking at that, like with conventional fuel getting more expensive? Have you like calculated out if there's like a breaking point where you can anticipate that the SAF will be cheaper than conventional fuel just because?
So I'm not a technology modeler, but I was in touch with Dan Mathistoff. He's a professor at Georgia Tech. He's into technology forecasting and whatnot.
Mhm.
But in his forecasting, I never saw those two lines coming together at all. Because the problem with petroleum is that since we are becoming very efficient on how we use it, right? So that is why prices are falling, right? So if prices are falling, or demand is falling as a result of prices falling, so it's very difficult to beat. But nevertheless, so think about that way. We don't use stones anymore, right? It's not like we ran out of stones, we just don't feel it that it is needed at all, right? Same thing can happen with fossil fuels, it will be there, but who cares? Because we have moved on as a society, as an individual. So for example, my brother-in-law has a Tesla. It's just amazing, and we went for Lake Michigan tour with family and all those things. And he's so used to Tesla, he doesn't know even how to drive a gas car anymore. Forgot to fill his gas. Somehow we managed the disaster, but that is how it is, right? We just got used to, and then we never feel that something which was very important is important anymore, just like a Stone Age or Bronze Age or Iron Age or whatever age you want to call, right? Yeah.
Is there any interest for SAF in the European region? Because you also mentioned about certification standards and the base of certification standards for like SBP is sort of in the Europe and where standards are made and like they're harmonized together. So is there any interest for SAF?
So I think interest is from Delta side because they are very interested to use woody biomass feedstocks, and they did some study in Arkansas to figure it out how to rationalize standards. But they themselves have not seen the results of that study, so I don't know what is going on there. And I'm in touch with Joanna, and she told me that she will come back to me if something happens to do more research on those lines, because without sustainability standards, Delta cannot buy even a gallon of fuel, no matter what, especially you are talking about woody biomass, right? I'm pretty sure in a matter of 6-9 months, something big will happen on those lines.
But these standards are like industry driven, like they're made,
Oh, yeah.
Delta made their own standards.
No, not Delta, they are going with
Oh,
third
okay.
party standards.
Okay.
But SFI standards, for example, don't talk with biology standards. So that's the problem because, and ultimately everything is forestry based. That's a very interesting complication there, yeah. But they have to rationalize it before it goes big, otherwise, I'm pretty sure Delta doesn't want to be New York Times front article, yeah. Getting blamed for deforestation in South Africa. It's amazing, all these big fortune companies, their only first objective of life is to not be on New York Times for long reasons. That is how every decision is made. Good, anybody else? No? Okay, but thanks again for your time.